Welcome back to part 2 of our growth series on this tennis ball. In this one we're going to be looking at a solver and how we can use the ripple solver to kind of give us a different look. I'm not going to say it's better, but it is kind of different and it has some cool features about it, and it poses some new problems which we'll tackle as we go, which is always fun to kind of tackle some little things that pop up when you change things. So we'll have a look at that, and then we'll also just look at how we can add some particles and just some secondary elements to make it look a little bit cooler. And then what I'm going to do is I'm going to split the flower Kinefx rig thing for the Megascans flower into a third part, which I'll release next week. And this is just so that it's easier to reference, as I think that one would maybe be something slightly different that you may want to use in a different project, and then it's easier to find it in a future video. So I'll just split that off into a separate video. So let's dive in and let's take a look at this. So I'm in the same scene as I was at the end of the last one, where we used mops to kind of grow this tennis ball on, and I don't have the ball on, but here it is here with all the hairs and stuff. So if we turn all this stuff off, here's our ball, and what we can do is go inside here and let's get going. All right, so we're going to take our tennis ball from over here and we're going to do some ripple solvering. Move this stuff down, and what do we need when we use the ripple solver? And this is new in Houdini 20. So if you're using an older version, the ripple solver changed a little bit. So I'm going to hit that. And if we hit play, nothing happens. And the way that this works is you need some sort of displaced geometry in the second input. And for this, we can just use a soft transform. And what I'll do is I'll just grab a single point. For now, I'll just grab that one and I will just move it out. So it's like that. And now if we hit play, you can see that it's using that as kind of like the deformation, and it's very slow. This is running real time and it's really slow. So we can change some things in the ripple solver. What I'm going to quickly just do is add a rest position. This is just sometimes very useful in these types of setups. So I have a rest and then it's going to the ripple solver. So we can just give it 2 sub-steps. I think that sometimes helps quite a bit. And then in this section, we can obviously change the wave speed. So if we hit play now, you can see that it moves through a lot quicker, which is more what we want. We want like a really fast simulation. We jump into our camera. The one thing you'll notice, it has this really cool like rippleness thing that you have, like you can see it's moving around. And this looks really cool, but I found when I rendered it with all the Megascans stuff going around, it got a little bit crazy. So I wanted to dial this back. So something we can play with is this conservation, and this determines how much energy is conserved in the system. So the velocity is modified by this rate directly. So basically the smaller this amount, if we hit play now, you'll see that this doesn't do anything because there's no velocity, and the more you increase this, the more the velocity goes through. So you can see it dies out really quickly. So we can just kind of pull this up and find a value where we get a nice fall off. So you get some ripples, but it's not too crazy. And maybe this is still too much. And we can turn that off and see what this does. Okay, so it's starting to feel better. And this rest spring, it's always good just to kind of hover or look at the help docs. That it determines the strength of the springs. So it determines how quickly we're going to get from this to this. So like if this is super high, it will try and do that really quickly. This conservation is kind of messing that up, but you can see now we can kind of dial in these values, and maybe this can be 0.5 and this can be 0.2. Let's try this. All right, so we get something that's quite cool. Maybe this is too high. And we can also pull this out further, and the further out it is, the more intense the wave will be, but then you can see it kind of dies out and there's just a slight ripple over the surface, which I kind of like this. Something else we can always just do is drop down a normal, because sometimes this messes up the normals. In this case, it actually seems okay. Maybe it's because I have this normal node over here. Okay, so now we have a bit of a ripple. Now, one of the things is we can pipe this into our animation, and we are now animating this. And that actually looks pretty cool. Comes up and then it like revolves around. And before I had the point in the front, but I actually kind of like it the way that it's doing it now. So I'm just going to keep this. But obviously we don't want this to start with this giant thing sticking out that looks mega weird. And so what I'm going to do is I'm going to use a blend shapes, and I'm going to blend shapes between these two. So let's go like this. And so on frame 1, I want it to be 1. so that we don't have anything. And then on frame 2, it can be here. Oh, maybe not 2. When it gets to about here, so maybe here it can blend, and before that I want it to be here. So basically, if we pipe this in, now we get a ball that goes up, and then so as it pops in, you can see that this is what we're starting with, which is pretty nice. And maybe this is just a bit too high, so let's pull it in a little bit. So I'm pretty good with that. So this is a cool little way to get around this giant thing sticking out over there, which obviously no one would want. And then as we move through, we realize we don't need this mop stuff, so we can just delete that. And then we need to remap, but we don't have mops, so we're going to remap it based on the something. And this is when I was like, oh, I don't actually have anything now. And of course, because this is kind of like still a spherical falloff, I could do something that could try and match this, but anything I would do wouldn't really work. So I started poking around and seeing, okay, what does this give me? And it has some output, and I see that there's a displacement. So if I click on this, you can see that I get something that's the leading edge, because this displacement is pretty much my leading edge, and anything that I would want to kind of use, I'd want to trail behind this. So what could I do with this? Well, I could easily just put here if at displacement. All right, so now I've got p-scale, and if we have a look at our little test setup here, here as it comes, we get that. But now, because displacement is only in a certain region, like this section here, once it's come through, then everything's going to shrink. So I need to kind of keep this behind here. And so we're going to use another solver, just a normal SOP solver, to kind of build up these values. And the only way that you can do something that's time dependent is with solvers. Now, I'm not always the biggest fan of solvers, but in this case, we have no choice. So what I'm going to do is just say keep displacement, so we know what this is doing. So if we dive inside, what we're going to do is we're going to use an attribute copy. And the main things that I want to do here is I want to copy my position, so that position comes in to the solver. And then what I want to do next is I want to create an attribute wrangle, and we're going to use this and the second input. Now, this is kind of confusing because the second input is actually input 1. So we're talking about just this first input here is this one over here, and this is the previous frame. So because it's a solver, it can hold the previous frame's information, and we can now just create something that will store this. And what we'll do is we'll call this next disp, and we're going to read up on the point function 2 or 1, sorry, so 0 1, and we want to read displacement, and at ptnum, our ptnum is not changing, so we're good. So essentially I'm just reading in displacement that's coming in, so it's the current frame displacement. But then I also have in this input, I also have displacement of the previous frame. So I can say that if displacement and, well, actually let's just do displacement, and this is the previous frame. If it's smaller than the current frame, which is next disp, then what I want to do is I want to say that displacement is next disp. So if it's smaller, I want it to be the next disp or its current frame. So if the previous frame is smaller than the next frame, match the current frame. And so what that will then look like, if we hit play now, you can see that it's kind of keeping the values up. But it's not exactly what we would want, as you can see here. And I do have some normal issues there. We can drop down a normal here just to fix that. And so what I'm going to do just before this is do an attribute remap. And I want to remap this displacement value. So if I have a look at displacement over here, I just want to crunch these values to something very high. Okay, so let's try this and see how this feels. Okay, so that's starting to feel a little bit better. And you can see that it's kind of filling out as much as we need. Let's try that. Okay, I think that's good enough. I'm not sure why that section is not. It could be that that section never gets fully displaced, and that's kind of what we're running into here. But let's see. Maybe this needs to just bigger. The other thing we can do is also just see that these values are really small, so we can kind of increase them ourselves. Just see what that gives us. Okay, so that kind of fills it up nice and quickly with this hard edge, and maybe we don't want such a hard edge. I think this will help us fix that. Yeah, so then we get something more like this. So you have a little bit of control over how things will work with this ramp. So for now, we'll kind of keep that and we blend it in. We still have our displacement. So now if we go to our lines over here, as these grow in, they grow in and they stay in. And I think this here is now giving us issues because of the changing point count. Yeah, you can see that these numbers are all changing every frame and it's going a bit crazy. I think it is. It definitely looks like it. And we can easily fix that with the attribute interpolate. We spoke about this in the last tutorial, where we just time shift this to frame 1. That goes up there. And then here we just have to output these values. So now we don't have any of that kind of stuff. And now this should feel a little better. Yeah, so now we get the growing and it's working as it should. And we may have to increase our p-scale because we've lost our normals. Let's see, okay, we need to get rid of that normal node and we get this. Some interesting stuff, but we'll solve that as we get going. So we get the same kind of leading fall off, and we may not actually need that in this because we're getting that from the actual displaced geometry. And so maybe what we do here is we just set this to be linear. So we just get the fall off based on the actual movement of the geometry. And maybe the displacement can be a little bit higher here. So if we have a look, see the displaced section is happening before we even see it. So we don't see our points on that, which obviously we can't have that. So let's just check at our actual displacement. Yeah, so you can see that our displacement is before. So as this is growing in, we're getting hairs before we see the cool movement of the sphere, which may be cool if we have the ball and the hairs. So if we jump out of here and we put our ball on, and let's just do grass clumps for now, jump into our camera, you can see that we would get this ball moving and then this. So I can just drop a render quick. So this is kind of cool because you see the displacement and then the grass is coming in behind it. So like this is a cool way to do it if you want this type of effect. But let's talk about how we can kind of fix it if we didn't want this. So first thing I need to do is just do an attribute blur, and I want to just blur this displacement because it's very pixelated now. And we can just get something that's a little bit more smooth. So if we have a look now, it's not as like pixelated, if you want to call it that. It's the wrong word, but you know what I mean. And then the next thing I need to do here is just get this to be closer. And if we have a look here, you'll see that this is what we're going with, and I don't want that. I want this to be okay. So these values are a little bit funky. So let's just fix it ourselves and get it something that's more on the leading edge. Where is that leading edge? Let's just give ourselves a little bit more of a higher pool here. All right, so that seems a little bit better, although here I want it to be over there. So let's just see where that is. There. Okay, so that's a lot better. So now I get the leading edge, and if we run it through this and the blur it, Okay, that's a lot better. So now we get the spike based on the geometry itself. So this is the spike. So that's pretty cool. And if we jump out of this and we look here, let's just turn off the visualizer. Okay. So now we're getting this on top of this kind of cool mesh. And if we jump into this and let's just, for good measure, just quickly hit render again, just so you can see the difference. So this was the before, growing before, and now this is the after where it's growing on top of that craziness. And of course, we can add just everything in there. Let's quickly have a look and see what that looks like. So you get this kind of cool, and it's very exaggerated, but the flowers themselves are small, but the actual geometry underneath is being displaced. So you get a very cool looking, crazy looking thing. So that is working quite well. All right, so that's cool. There's some weird normal stuff going on here. So if we just drop down new normals here, we can kind of fix this weird normal in the one section here. And that feels a little bit better. So before and after, and especially in the starting section, it kind of does some weirdness, but we can see it like that. And let's just give ourselves a bunch more points. It's a bit hard to see what's going on here. Yeah, it's kind of like knitting, but on a tennis ball with some plants. But it's very much the same idea as knitting. You can watch the knitting series, but you would just use like a dot product to turn these around and they would knit on top of each other. But it's kind of a similar approach to things. Okay, so we are getting this working. And so the next thing I want to do now is just talk about the particle hits that we did. And just to double check that this is looking what it's supposed to look like before I move on. Yeah, so this is looking pretty good. And it just kind of goes through and moves as it should. So there's the tennis ball fully done. And in the beginning, there's nothing, and it have this massive growth thing here. And this is probably a bit too high, and you can play with it, but you can see the settings are all just over here, and you just set this soft transform to be a lot less if you want it to be less. And if you want it to be slower, you can change the wave speed, and you can of course just do a retime afterwards. So it has this like boom impact and then slows down. And we've spoken about that many times in other tutorials, so you can do that. All right, so let's create a new geo container. And we're going to call this particle explosion. I don't know what this actually is, but this is going to be kind of like the little bit of grass that kind of shoots off as this grows in. So what we want to do is just grab this base mesh and let's just paste it in here. So we have our base mesh here, and like we've done before, we're going to just time shift this and set it to frame 1. We're going to do a scatter. And then we're going to do an attribute interpolate. And this is just to get some points on our mesh that we can use. And so now we have this. Why is this simulating? It's a bit weird. I guess it's simulating from the other container. So we have that. And here, let's just do something like 5,000 so we have a nice dense number of points. And what I want to do now is I want to run this through a pop sim, but obviously if I do this, pop network, not pop sim, I need to go inside here and just say, first let's turn off this guard. I'm going to say all points. And if I hit play now, you can see that it just births every frame because it's taking all the points and it just keeps birthing them. So what I want to do is I want to kind of use that leading edge to delete some points. So we can use an attribute wrangle. There's a bunch of ways that you can do this, but I'll do it like this. Delete points. So the first thing I want to do is I want to create a length attribute, and this is just going to be the length of the vector. So if we have a look at our velocities, as this is moving, it creates velocities, I think. Maybe it's not creating velocities. So I can do that by just creating a trail over here. I guess here. I need to set it to actually do what I want it to do, compute velocity. So now we have velocities. And so now I'm creating the length of this. And what this is meaning is that points that have a high velocity will give me a float that's higher. So I can very easily just say if at len, or just len, I'm not creating an attribute, if it's smaller than a certain amount, and we can just say len amount, then I want to remove 0.0 at ptnum. So I can create this slider, and now as I move this, we'll see that some points are deleted because turn that off. Okay, that's not quite giving me what I would want. So let's just double check. The ripple solver should output a velocity attribute. Maybe I need to tell it. Okay, I need to tell it to output a velocity attribute, and then it should do that. So if we have a look now, we have velocity, and after this, we don't have velocity. So we just need to make sure that we attribute copy velocity as well, so that through our solver we get velocities too. And now this should act a little bit more like we expect. Not quite though. Oh, I need to get rid of that. Okay, so I didn't want to get it because this trail was calculating with the animation of the ball flying up. That's why everything had velocities. Now I'm just getting on this main burst, and you can see this is kind of what I want. So as it kind of flies in and starts, I get some points, and then they slowly die out. So now if I hit play on the popnet, I get some points. Now obviously the velocities themselves are doing something crazy, and we'll fix that now. So the other thing I have here is I have a normal attribute, and so what I'm going to do is I'm just going to create another attribute wrangle, and this is going to be to set the velocity, and I want to just set the velocity to be that of the normals. Goes in. So if I hit play, they go outwards. So they just take the ball's normals and they move them outwards. And we can add a point velocity, and we can just say keep incoming, but add a little bit of curl noise, and let's just see how this looks. Okay, that's maybe a little bit too wild. So let's turn the scale down and the swirl size up. Maybe a little bit different. Okay, let's try that. All right, so that's starting to feel pretty good. So let's dive inside here, and we can add, as usual, we can just add some pop wind, and just this is just to kind of give it a little bit of random motion, something like that. Probably be good. Yeah, so that feels pretty nice, pretty organic. Just maybe it's a little bit strong. We can also add some pop drag so that as these shoot out, then they kind of just slow down. And let's give it a bit more. And then what we can do here, let's just turn this down. When you attribute adjust vector, and I'm just going to push the velocity because this is only going to happen on the first frame. So what I want to do is I want to just make this like very strong so that they kind of shoot out. Boom. Maybe even stronger. Yeah, so that these will move out and then they kind of chill out. And this is maybe a little bit strong. And then the other thing I want to do is just add some pop spin. And the reason for this is if I just do let's do maybe a tube. I just want to show direction, and this is a good way to do that. And then if I do a copy to points, now these are not going to have the right direction per se because they're not on the right axis. But if I do this, you can see that they're all exactly the same. And this is way too big. Let's just drop down this. They're all the same, and this doesn't look super realistic. So what I want to do is I want them to have just slightly random rotations as they shoot off. And I can do that with this pop spin. And we've spoken about this before, but we can easily just say 360. And on its own, this doesn't do too much. In fact, it makes it worse. But we can, because what this is doing is it's just setting them all to the same thing, but we can set a random axis. So we can say random at ID, and this is set by the pop solver. And then we just need to center this. So we get kind of like normalized values. And then spin speed, this is just so that they actually rotate around and they aren't just static. Again, we can just use a random number for each particle so that they're not all the same. And then we're going to multiply it by the length of v. So, and I used just a multiple, so that the ones that are moving quickly are going to spin quickly, and the ones that are not, they would slow down. And this is kind of more realistic. So you can see that as they shoot out, they spin, and then they slow down and they chill out. And we can maybe make the length of their life a lot less, but I think I ended up doing this in post, where you can kind of just fade them out with a wrangle, so attribute wrangle, and we can just say if at p scale times equals, and there's an attribute called age, which is a normalized age over life. So basically, as particles get bigger, I mean, as they get older, they die out. And I think this is the invert of what I want. So they start off big and then they get small, and we need to fit this to something. So let's just fit age from, I don't even know what age could be, like let's say 1 and 50 to be 1 and 0. Let's just see how that looks. Okay, this is too high, obviously. 2 and 0. Okay, that's not working. So let's just invert it here. So I know this is 2 or 1 and 0. Okay, or 0 and 1. I guess I'm inverting it on that side. So they start off big. And then they start to get smaller, but now they're all uniformly smaller. And so I can just multiply this by a rand at ID. And then they'll slowly die out. The other thing you can do is inside here, we can change their life. So in this birth tab, and again, I don't want to emit particles every frame. So I can say that if it's smaller than, let's say 40 frames, it can kind of birth. And maybe the life expectancy is like 1.5 with a variance of 0.5. So some will live for 1.5 frames, which is like, I don't know, 35 or 60 frames, whatever. And then they'll slowly die out, and you can see then they die out. So they come and then they die, and maybe they can live for a little bit longer. So we can make this 3, the variance of 1, and 40 is good. So boom. And I think this pop drag is still too strong, so we can just turn this down. Because I want these to shoot out quite far. So that's pretty good. And I want them to keep moving, so this pop one can go higher. So let's try now. Let's just see it in our whole scene. That camera. Okay, so you can see that this is a bit wild. But obviously these test pieces are really big, so we can just make them a lot smaller. All right, so now we get this grass, and that's way too much. It's always good to test it in a scene because you realize how big everything is once the scene is going. This can go way smaller. Yeah, okay, so that's cool. I think right now there's too many points, so we can just come into this delete points, and here we can just set this to something higher so that there's even less points. Okay, so let's just try that. Yeah, so that's pretty cool. Maybe a little bit more points, and this is now just finicky and playing around with different iterations. But you can see we have our ball, and then as this explodes out, we get all these extra kind of pieces. And obviously I don't want to use tubes, I want to use like pieces of grass. And so what I ended up doing here was, again, relying on OD tools. I can go into these atlases, and what these atlases are just like images. They are not actual geometry, but OD tools kind of makes us geometry. So we can, there's a whole bunch of different ones, but if I search for grass, you can see that there's all these different types of grass, and I don't think at this point it really matters, but let's go with swamp grass. And then I can say redshift, and then what this is doing is it's creating actual geometry for me. And there's a whole bunch of options here. I don't really play with them a whole lot, but it's also got materials and it assigns them. And now I have these pieces of grass. So I can transform them. I don't even think I need to transform them. Maybe I just need to scale them a little bit. Maybe they're a little bit big. So let's just scale them down, and then let's just copy them and see what this looks like. We obviously need to, not obviously, but we should use the variant attribute. And then let's use an attribute from pieces and grab that variant attribute over here. And we just want to use a like random variant attribute per piece. And what I ended up doing, because we just copying onto points, I can just add a bend just to kind of give it some random bend. And this needs to be up on the Y. And then let's just move it down. Capture origin. Yeah, let's move this down. Oh, actually, let's go after the transform, then I don't have to do it so high. 0. That, and then like that. Okay, so something is that this at the moment has just a single polygon, which obviously is not what we need. But in this atlas, you can tell it how many subdivisions you want. So I want 2. So now my bend is actually bending this. So that's why it was not doing what I wanted. So when we copy this now, you can see that these have a little bit of rotation. Now it doesn't look amazing, but remember that these are going to be tiny little grassy hairs that you're hardly going to see. They're not going to be this big because we can go into, this changes the name of this, which is kind of annoying. This, what do we call this? Particles. Let's just add attribute randomize, and what we want to do here is just randomize the p scale, and we'll just set it to our own values, so we're not going to actually rely on the popsim itself. Okay, so we get something that looks like this, and that's jittering like crazy, and I think that's because we need to set this variant to be based on IDs and the p scale to be based on IDs. Let's just see. Yeah, that's way better. It was just swapping variants randomly. And then if we jump out, let's just turn off some of these. We don't need all of them, we don't even need any of them. Oh, let's just keep the amaryllis just so we can kind of have a base of what this looks like. And this is obviously still way too big, so let's just turn these down even more. So now we just have all these little pieces that shoot off, and they kind of float around and they just chill out and then they die. And maybe that dying is unnecessary. So again, this is all art directable. You can kind of come in here and just say that these are going to live forever. Fine, they can live forever. And you can push them off the screen if you wanted, but there we go. They float around and there's some extra details in these little pieces of grass. And as always, I would just pack an instance and then add a new render grass. Red. And I like to do this just so that I can very easily turn layers on and off while I'm rendering. It just makes it a bit easier to know what's where. I need to make sure that this is set to instancing, swap level, back primitives, and now you have these graphs here. And of course you can play with these materials, and these are still way too big, but you kind of get these really nice, like secondary little pieces of grass. Let's just go in here. I definitely don't need displacement or bump map. Let's just turn on translucency, and let's just do a color correct, and let's just pump up the saturation just so that these are nice and saturated. Doesn't really seem to be doing too much. I think translucency kind of takes over a lot of the color when it's turned on. So now we have this really nice bright green grass. That's maybe a bit too neon, but that's okay. And it shoots out. This is the basics of this, and I think it's kind of fun. It's different, and it's maybe not always what you would want, the ripple solver, but it's a fun to have another approach that works, that you can kind of get the fall off and all that. And these grass elements I've used on several projects where you just want to add some secondary debris, if it's a rock, or grass if it's, you know, this kind of scene, and it looks pretty cool. So I hope you enjoyed this one. I'll see you next week where we'll do the flower with Kinefix.